A new Spring Boot application feels incredibly fast to build, but as business requirements pile up, that initial speed becomes a liability. A simple system scales into a tangled web of dependencies and eventually begins to buckle under its own weight. Most developers are taught the standard 3-tier architecture. You receive requests in a controller, write your business logic in a service, and save to the database using a repository. This chart maps that flow. But if we look closely at the end of the chain, specifically the service, the JpaRepository, and the Postgres database, we find the exact point where the architecture breaks down at scale. By directly injecting a JpaRepository into a core @service class, you tightly couple pure business rules to a specific framework. Your logic is now permanently tethered to Spring data and a relational database. When you mix domain rules with SQL implementations, refactoring becomes nearly impossible. Changing a database schema or swapping out a persistence framework means rewriting the core logic of the application. The traditional MVC structure forces a permanent marriage between your domain and your infrastructure, making it a trap for enterprise-level systems. The alternative is organizing code by feature, often called modules, while enforcing strict inward-facing dependency rules. This is known as a modular monolith with clean architecture. In MVC, creating a user takes 4 files. In clean architecture, that same user requires 10 distinct files. It looks like over-engineering, but it enforces a strict division: API, application, domain, and infrastructure. Each folder is a hard boundary requiring explicit translation. We are going to trace a single post request to /API/users through these 10 files to observe how this isolation works in practice. The request begins at the API layer. A JSON payload strikes the outer edge of our application and hits the user controller. Here, the controller acts solely as a translator. It ensures the JSON is mapped into a highly specific create user request data transfer object. The controller calculates nothing and decides nothing. It contains 0 business logic. It takes that clean DTO and immediately passes it inward to the application layer. Keeping this layer devoid of logic protects the rest of the application. If the UI payload changes, or if you migrate from REST to GraphQL, the disruption stops right here. The flow moves inward to the application layer, specifically the create user use case. This layer is an orchestrator. It directs traffic and defines the steps of the process, but it does not contain the core business rules. It receives the DTO, initializes the core domain object, and commands the repository to save it. Notice what is missing from this file. There are no web-related imports like HTTP serve request, then no database-related imports like JpaRepository. The application layer creates a secure boundary. You can execute and test your business flows without ever needing a web server or a database connection. Now we enter the deepest, most protected part of the architecture, the domain layer. Look closely at the user domain model on the left. It consists entirely of fields and methods. Compare that to the standard JPA entity on the right, which is littered with @table, @column, and @ID annotations. Removing those annotations is intentional. The business object defines what a user is and what a user can do. It should not care how it gets stored on a hard drive. This folder also holds the user repository interface. This interface is a pure Java contract. It dictates that a save method must exist, but it emphatically does not extend Spring's JpaRepository. The domain dictates what it needs to function. It remains completely ignorant of the fact that Spring, JPA, or PostgreSQL even exist. To actually save data, we have to move back to the outer edge where the framework lives, the infrastructure layer. Here we find 4 specific files. First is userentity.java. This is where all the JPA annotations and SQL table mappings are safely quarantined. Second is Spring Data User Repository. This is the interface that actually extends Spring's JpaRepository to talk directly to PostgreSQL. Third is the user mapper. It translates the pure domain object into the database-specific entity. Finally, we reach the implementation, user repository impl. This implementation file satisfies the pure domain interface we saw earlier, but under the hood, it secretly delegates the actual SQL execution to the Spring Data User Repository. The infrastructure layer absorbs the framework requirements, allowing the rest of the application to remain independent of the database. We have traced the complete lifecycle of a single request, The power of this design is visible in its strict dependency rules. The API, application, and infrastructure layers all point arrows inward to the domain. The domain layer points to absolutely nothing. Writing extra DTOs and mappers for simple CRUD operations takes more time up front. But consider what happens when your company decides to swap out Postgres query for MongoDB. Because of the inward dependency rule, this migration requires rewriting only the infrastructure folder. Your core business rules remain entirely untouched. The 10-file structure acts as a firewall against cross-module pollution, keeping the codebase testable and modular as the feature set grows.